This meeting is being recorded.
In problem 9 from chapter 20, we are asked to rank each set of compounds in order of increasing acidity. So we'll divide this into two parts here. So first we'll start with the compounds that are listed in group A. And we have to remember, in order to rank acidity, we generally have to assess the relative stability of our conjugate base. And we'll also, in this case, have to look at the nature of our substituents, whether or not they are electron withdrawing groups, such as chlorine or other electronegative atoms. Bromine also can be included in that list. And those electron withdrawing groups tend to stabilize our conjugate base, versus if we have electron donating groups, such as alkyl groups, they tend to destabilize our conjugate base. So we'll keep those in mind. And then overall, the weaker the conjugate base, the stronger our conjugate acid would be. So let's look at these three compounds from part A shown below. So first we have 2,4-dichlorobutyric acid. So we know that's the common name for the butanoic acid, which is 4 carbons in length. So that's what we see here. So each of these, the similarity is that they are a carboxylic acid that has 4 carbons on their longest chain. So we have, again, 2 electron withdrawing groups at carbons 2 and 4 here, versus 2 electron withdrawing groups at carbons 2 and 3 here. So far, this acid here in the middle will be the strongest of the 2 acids because of the proximity of those electron withdrawing groups. Then we see over here, our last compound all the way on the right, it has 2 alkyl substituents or electron donating groups, both on carbons 3 here. So those would actually destabilize our conjugate base, making our conjugate acid the weakest. So this will be the weakest out of this group. This one in the middle will be the strongest, again, due to the closest proximity to our acidic hydrogen here being with these 2 electron withdrawing groups on carbons 2 and 3 compared to carbons 2 and 4. So we see our strongest, number 1 here, but we're supposed to rank these from increasing acidity. So this one would be first, our weakest, then we would see this one be number 2, and then our strongest would be number 3 here. Let's see if we can do something similar in part B. So I have our compounds shown below here. And just so we can keep track, we have a 3-bromopropionic acid. That's the common name for propanoic acid, a 3-carbon chain carboxylic acid. Then we have 2,2-dibromo and 3,3-dibromo. So now we just have to look at electron withdrawing groups in comparison here. So again, we have carbons 1, 2, and 3. This has an electron withdrawing group on carbon 3, 1, 2. This has 2 electron withdrawing groups on carbon 2. And then this last propionic acid has an electron withdrawing group on carbons 2 and 3. So again, due to proximity, this will be our strongest acid. This guy over here will be our weakest, both due to proximity and the number of electron withdrawing groups. And this will be number 2, somewhere in the middle. So the weakest here, 1, 2 in the middle with the 2,3-dibromo propanoic acid. And then our strongest will be this one in the middle.